So MPLS, what we have learned is the fundamental. MPLS generates label, LDP distributes label. Now, just distributing label, using the label for packet forwarding is not the reason why we go for MPLS. We also have something more better. What is that?
Could you mute?
To avoid fully mesh in
I
BGP.
muted already. So
Okay, it's okay.
okay,
Sorry.
thanks.
To avoid fully mesh in BGP, we want tunnel between the IBGP edge routers. If you want tunnel between these two routers, which are in the border of our autonomous system, we need BGP support. Sorry, we need MPLS support. MPLS provides us the tunnel VPN so that you don't need to have full mesh. MPLS provides a virtual circuit using which you can send the updates, you can send the interesting traffics end to end. For example, uh-oh, you got big autonomous system and you got some routers and you don't know what topology you have. Physical topology, you really don't know. It can be anything. It can be linear, serial. It can be full mesh. It can be hub and spoke. It doesn't matter. It doesn't matter for you. You don't care. You know, hub and spoke or whatever. You don't care. You need an overlay. You need an overlay between this and this. You want a point to point. You want your next hop to be the other end of the autonomous system, for which we need an MPLS support. We need MPLS VPN. If no VPN, then you have to enable BGP on every single router, and you need to have route reflector, or you need to make full mesh, which is all headache that we learned in BGP classes. To easy our work, to avoid those headaches, you need to have tunnel between these endpoints so that the routes that are coming from other autonomous system, which needs to be advertised to remote office, can go like this. See, it is agnostic to the physical topology, the hardware. The hardware says you need to go like this, and go. You don't care now about these zigzag routes. All that you see is in this router, you see this as a next hop, and you forward the packet to that next hop, and it reaches the remote office. So, network A is seen in the routing table of the remote office. Network B is seen in the routing table of this local office. And none of this router knows about A or B. No A, no B. They don't know anything about A or B. Yeah, they don't have any in route information to reach A or B, but still A can ping B and B can ping A. It is because we have used this tunnel. Yeah, so tunnel is good. VPN services are good. MPLS supports this. Sorry, BGP supports this. BGP works along with MPLS to provide you this tunnel. MPLS is one of the protocol that can work with BGP. So when we say MPBGP, it is not meaning MPLS. Multi-protocol BGP, meaning one of the protocol among this multi is MPLS. MPBGP and layer 3 MPLS VPN are not same. Layer 3 VPN using MPLS is one of the feature that MPBGP supports. Is one of the feature that it supports. Yep. There are many other features that MPBGP can support. One is BXLAN EVPN. That is also MPBGP. VPLS. That is also MPBGP. VPLS can be done with MPLS as a layer 2 VPN. That is layer 2 VPN. This is layer 3 VPN. VPLS is also one of the product of MPLS. Virtual Private LAN Service. Virtual Private LAN Service, which is layer 2 MPLS VPN. This is also one of the features that BGP supports. IPv6 BGP, that is also another feature. That is why it is called as MP-BGP. So one of this MP is what layer 3 MPLS VPN. So sometimes people will think MP-BGP and layer 3 VPN is same. Layer 3 VPN is one of the service that MP-BGP supports.
Jay,
Yes.
MPLS or L2
VPN. Both are same.
L2 MPLS VPN.
Both are same.
Also, L2 MACsec is the same.
MPLS, MACsec. No, they're not same. They're not same.
What is that, the MPLS Max? Max security. L2 Max security.
No, it is not same. It is different. All right. So layer 2 VPN, we have XConnect, we have VPLS. We can have layer 2 VPN with MPLS, without MPLS, with MPLS as VPLS. Anyway, in short, what I'm trying to say is BGP supports layer 2, layer 3 VPN with MPLS, without MPLS. Without MPLS is EVPN, VXLAN, which is also supported by BGP. So our focus is not all of them. Our focus is layer 3 MPLS VPN today. This tunnel that you see here is layer 3 MPLS tunnel. that you are going to construct in between this provider edge 1 and provider edge 2. You don't need to do any configuration on the middle routers to achieve this. Only on these two provider edge routers. The middle routers need to be a transport. You need to ping between this PE1 and PE2, for which you will be running some IGP protocol. Recommended IGP protocol is a link state routing protocol. It can be ISIS or OSPF. So this is layer 3 VPN. What is that? Your customer, let me call C as customer A, customer B. If customer A and customer B wants to reach each other, ping each other, customer A should advertise this network, A network, the prefix A, to the provider. Provider learns the route in the routing table and takes the route and place it into the VPN tunnel. So, in the routing table of the provider, customer route is seen. Understand this. Will provider learn the customer route? Yes. But not on every router, only on the PE router. Only on the PE router, the network A will be seen. Likewise, the network B will be seen on this PE router. Customer B is advertising the prefix B, it is learned. And you see, inside the router, I put one small rectangle box. What it is a separate routing table. It's a separate routing table for that customer we have created. It's a separate routing table. So you got global routing table, which is default routing table that has got reachability to all these local networks. And we got another routing table which will be connected to this VPN alone. Customer routing table is connected only to the VPN. So whatever customer A advertises, it gets redistributed from this routing table, not from the default routing table. From the customer's routing table into the VPN. So VPN is not going to carry any local network. VPN can now receive only those routes of the customers because it is connected to the customer's routing table. VPN tunnel endpoints are not attached to the default routing table. It is not attached to the default routing table, only to the customer's routing table. So from
Likewise, there will be hundreds of VRFs, right? For other customers.
For each customer.
So this is ISP setup.
Yes, service provider, correct. So you may have hundreds of customer. For each customer, there is going to be a separate routing table and VPN. So how many BGP VPN peering you will have? Between these two PE routers, you will have only one BGP peering, but inside that VPN, all 100 customers' traffic will go, but they will not get mixed. They will not get mixed up because we are going to use a value called route target, which is going to differentiate the routes inside the tunnel. And we are going to use another value called a tag called a route distinguisher, which is going to say that this these traffic belong to customer 1. The other traffic belong to customer 2. So route distinguisher is one of the tag value which will say from where these routes are coming. Route target is the one which is going to distinguish the route in the VPN and say these routes are targeted to this particular remote customer. So some people will say for 100 customer 100 VPN, because for 100 customer there is 100 different taggings to differentiate. In that way they are right. But I always see it as only one VPN. Why? Because the BGP VPN configuration that I do is only one. I form one peer. From P2 I make P1 as a peer. In P1 I make P2 as a peer. I just configure only one peer, which establishes this virtual tunnel. In that way, it sounds like only one VPN, MPBGP, layer 3, MPLS VPN tunnel is only one. But inside the tunnel, you have another tagging to separate 100 traffics from 100 customer. That if you focus on that tagging, then you will say 100 customer, 100 VPN. See, for me, both are correct. It depends on from which angle you see. If you will ask me, do we have 100 VPN or not? I'll say yes, of course, we have 100 different taggings, then 100 different encapsulations. If 100 different encapsulations, then 100 VPN. But if you will ask me in BGP command to show 100 VPN, no one can show. It is only one peering that you do. One remote site, one peering you do. That brings up the VPN. In that way, it is only one VPN. Because you can see only one configuration. If you type show BGP VPN v4 unicast all summary, you will see only one VPN up. But inside there are 100 VPNs because you got 100 different tag for encapsulation. Right? 100 different tags, 100 VPNs. Any other question you have? I think I answered the sorry now.
I have a question.
Question, please.
Yes, we have PE1 and PE2. That's on different sites, right?
Yep.
So the routers in the middle, we can do we have to see like ISP routers?
Yes. They're all internal to the service provider. According to our traffic, the traffic that is going from this point,
Yes.
this is just going to be one hop.
Okay. Got it.
Even when you trace route, you won't see all those middle routers. That's why when I trace route from here to a web server in London, I can reach in 5 hops or 6 hops. Do you think we have only 6 routers? No. There are 6 autonomous systems, big ISPs. It goes from one big ISP from India out to another ISP somewhere in the middle, maybe Etisalat, and from there maybe Telecom Italia, and then boom, it's there in London. So the number of hops that you see in trace route are not the real hops. It only can show you the autonomous systems in the path. All the middle routers, for security reason, they are not revealed. That's good actually. It is not only reducing the number of hops, it is also good for them security. ISP's internal networks are not revealed. Only those public facing interfaces are shown. Internally, they have private networks, those are not revealed. Okay, so MPLS supports this VPN, layer 3 VPN. What is layer 2 VPN? Again, I draw this ISP. Again, I draw another provider edge router, another provider edge router, and again you got another lot of inside routers. Now I have a customer edge 1 A side, customer edge 2 B side. Now between A and B we want to reach. Now layer 2 VPN is also done using BGP and MPLS. This also comes under MPBGP, but the difference is this. You see the tunnel endpoint. Here the tunnel endpoint, I have placed it right here. Inside the router. Route from the customer comes inside the routing table and get redistributed inside this tunnel. Whereas it is outside. Meaning the customer routes are not going to be learned in the provider's routing table. Customer route, when customer advertise, they are not going to be learned. They're not. Whatever customer advertises through this link via this port, whatever he sends out, it'll go straight like this. According to this router, CE1, CE2 is the next hop. Totally, this provider is being hidden. Is hidden. The provider is totally hidden in layer 2 VPN. In layer 2 VPN, see, it is layer 2 VPN, which means here if 10.0.0.1, definitely here also it should be 10 subnet. Whereas if here it is 10.0.0.1, it cannot be 10 here. It can be maybe 172. Because it is layer 3 VPN. From here to here one routing, and then it goes from here to here via the tunnel, and then again here to here routing. This is different network. Sites are in different network. Then you need layer 3 VPN. When sites are in same network, you need a layer 2 VPN. You don't need routing. You want the ISP to be seen as layer 2 switch. If an ARP request is sent, ARP reply should come from here. Our reply should come from here, which means it's only the MAC address that is involved in moving the packet. No routing anywhere because the routes are not learned in anywhere in the middle. It's only layer 2 tunnel. Yeah. So this is the big difference between layer 2 and layer 3 VPN. Layer 2 VPNs are like the virtual environment creates a switch environment where normal switching happens by learning MAC address. No routing is involved and it is more safe also. The provider will never know anything about your network. Whereas in layer 3 VPN, the provider edge learns the customer's route. Another difference, the customers are in different subnet, so they need layer 3 VPN. Here the customers are in same subnet, then they cannot go for layer 3 VPN, it is layer 2 VPN. Configuration point of view, layer 2 is very easy than layer 3. Yes. Layer 2 is very easy than layer 3. But layer 3 is what you will enjoy doing it. That is the truth. But layer 2 is easier than layer 3. And layer 2 is what most of the people, my knowledge, they use. Especially in Middle East. This is enabled between the airports. They use layer 2 VPN between Salalah and Muscat airports. I have seen also between different other airports. It is only L2 VPN, VPLS. So in our class, we will start with layer 3 VPN and then we'll switch to layer 2 VPN once we master layer 3 VPN. Layer 3 VPN will take some long time to understand and do, but it will be interesting. It won't take much time for you to learn VPLS. VPLS can be done in one day. For this, at least we'll spend 3 days, layer 3 VPN. All right.